Hey guys, so continuing on with 12.1, I've skipped this slide and I'm doing this slide and then I'm going to go back to that slide. So just letting you know that's what's going to happen here. All right, so I want to talk about some more vocabulary type stuff. We have something called the zero matrix, which is pretty much exactly what it sounds like. It's a matrix with all zeros. And then we have something called an additive inverse. So an additive inverse, when we're talking about just regular numbers and not matrices, would be like 3 and -3, right? Those are additive inverses of each other. And then when I add them together, I get 0, which is the additive identity. So an inverse is something that when you combine it with its inverse, you get the identity. So let me write down a generic additive inverse. So if I just have a generic matrix A, B, C, D, then its additive inverse is just going to be all the additive inverses of the elements of the original. And when I add them together, right, I would get A minus A is 0, B minus B is 0, C minus C is 0, and D minus D is 0. So if I add them together, I get the zero matrix. So this is the additive identity. The additive identity. So things that we know about identities. When you combine an identity with another thing, that thing doesn't change. So for example, 2 plus 0 is still 2, right? So the additive identity when we're just dealing with numbers is 0. The additive identity when we're dealing with matrices is the zero matrix. For a contrast, we also have a multiplicative identity, which is 1, right? If I multiply something by 1, it doesn't change. 2 times 1 is still 2, just like 2 plus 0 is still 0. So the additive identity in numbers is 0. The multiplicative identity in numbers is 1. So we can have different identities depending on the operation that's going on. So the additive identity for matrices is the zero matrix. So if I add the zero matrix with any other matrix, I'm not going to change that matrix. It's going to stay the same. And that's going to be important. And we'll talk about that in more detail in a bit. Okay, so we have an additive inverse that's just changing all the signs, and we have the additive identity where if we add something with its identity, it's not going to change, and that's the zero matrix. So with all of that being said, let's go back to this slide, which is about solving matrix equations. So if I want to solve a matrix equation, these are simple matrix equations. Basically, they work just like a linear equation. If I add the same thing to both sides or subtract the same thing from both sides, I haven't changed anything. I'm allowed to do that, just like with regular equations. So here I have an unknown matrix minus this matrix equals this matrix. So to get rid of this matrix, I can add it to both sides, just like we would normally do. So I have 2 minus 2, 0, sorry, 2, negative 2, 0, and 2, negative 2, 0. So I'm adding it to both sides. Sorry, I kind of ran out of room there. And that negative doesn't look negative. There we go. I'm adding it to both sides. So this is negative. This whole thing is negative, which means that what I really have here, I could rewrite this as I have plus negative 2 to 0. So if I just change the signs on everything, that's really what I have here because it's a negative matrix. So a negative, I can rewrite a negative matrix by just distributing the negative like I would do if I had, say, numbers in parentheses, right? And I just distributed the negative. I can do the same thing with matrices. I just have to change the sign of every element in that matrix if I have a negative outside. So this is essentially what I have here. So if I add these together, I'm going to get the 0 matrix, right? I have negative 2 plus 2 is 0, 2 plus negative 2 is 0, 0 plus 0 is 0. You don't have to do this each time. You can know that if I'm subtracting a matrix and I add the same matrix, I'm going to get the 0 matrix. You don't have to go through this process. I'm just showing you that this is what happens. So if I have A, essentially now I have A plus the 0 matrix equals, I have to add these together. So I have 1 plus 2 is 3. Negative 4 minus 2 is negative 6. 5 plus 0 is still 5. So I have A plus the 0 matrix equals this new matrix. Remember what I said about additive identities. If I'm adding the 0 matrix to something, then this something is not going to change. It's just like adding 0. So I have A equals 3, negative 6, 5. So we can skip that step of finding the 0 matrix here because we know that if we add the same, if we're subtracting something and we add the same thing, that we're going to get the 0 matrix. So we can skip that step. I just want to show you why that works, okay? So this would be our final answer. A equals this matrix, 3, negative 6, 5. So let's do this one without the extra step. If you have questions, let me know, of course. So I'm going to erase because I don't have enough room. So this time I'm adding, right? I have a matrix that plus B that equals another matrix. So I have to now subtract to get rid of this matrix because I'm adding. So I have to subtract to get rid of it. So I'm going to subtract this matrix. But remember what I said about subtracting a matrix. I can just distribute that negative throughout the entire matrix. So I can make this a plus, and I just change the sign on everything inside the matrix. So now these are all positive, and this is negative. Notice that this is the additive inverse of this. So if I added them together, I would get that 0 matrix. I'm going to skip that step, but that's why this works, okay? So now I have B on this side because if I added these together, I'd get the 0 matrix, and so that wouldn't change anything, so I could get rid of it. So I have B on this side, and then on this side, I have Negative 6 plus 3 is negative 3. Negative 13 plus 10 is negative 3. Negative 1 minus 4 is negative 5. 1 plus 10 is 11. So this is B. Negative 3, negative 3, negative 5, 11. So we're just adding or subtracting depending on what we need to do to get the unknown matrix by itself, and then we're just doing that. So that's solving matrix equations. Hopefully it's pretty straightforward. Hopefully I wasn't too confusing with the whole zero matrix thing, but I thought it was important for you to understand why we can just get rid of that matrix when we add it to when we subtract it to the other side, which makes sense because that's what we've been doing with linear equations, but the rules with linear equations don't always work exactly the same with matrices. So I want to make sure we understand why things are working the way that they do. One last note, remember that in order for me to do this subtraction, these two had to be the same size matrices. So if you ever have an equation where they're different sizes and you're trying to add or subtract them, then that would be unsolvable. It wouldn't work. There would be no matrix that would give you a different size equation. So essentially it would be no solution. So if you ever had two different size matrices, that would be no solution in this case. All right, hope that helps. Let me know if you have any questions, and I will see you in the next video.